Hello, Legacy Sabers, Marsh here. So today we're going to do some factoring. Whoop, whoop. We're going to solve some quadratics using factoring. You're going to want your notes and your foldable today. So our essential question today, how do you factor and solve a quadratic equation? So first, let's review how to solve. So remember, solving means get x alone. So on a problem that would look something like this, we would subtract 2x on both sides, right? We get negative 3 equals 3x plus 7, and then we subtract 7. We get negative 10 equals 3x, so x would equal negative 10 thirds, right? Something similar to that. Now, same thing. I would add 5 over. I would multiply by 2, because I would divide by a half, but dividing by a half is the same as multiplying by 2, and I would get x is 36. Very simple, right? You're like, snore, I know how to do this, right, Marsh? All right, what if you have a squared? Well, that means we're going to get two separate answers. So you would take the square root on both sides. And remember, if you got the square root, if you took the square root of both sides, you got a plus or a minus. And then we would get the square root of 16, which is 4. Okay? Because if it's a squared, that means you have to having to get two answers. Let's try it again. This one, though, I got to divide by negative 2 first. I'm going to get 81. Take the square root on both sides. We will get x equals plus or minus 9. Very quick, very easy problems right there. Now, let's talk factoring. You've probably factored quite a bit in your life. This is kind of a review lesson, but it also is just making sure that we understand factoring really, really well. So when should you use which techniques while you're factoring? Whatever polynomial you have, the first technique you're always going to want to do is factor out a greatest common factor, a GCF. You're going to want to see, is there a GCF available for us to factor? Sometimes there is, sometimes there isn't, but it's always good to check for it because it makes your life a lot easier. Once you do that, there's 3 different steps that you can do. If you have a binomial, and right below that, write this, it has 2 terms. Okay, you're going to do difference of perfect squares. So you're looking for 2 separate things, 2 things with a symbol, a plus or minus in the middle of the 2. Trinomial is when you have 3 terms. Okay, there is 2 different kinds of possibilities. One with the front number, the guy in front of the x squared, being just a 1, and one where your value in front of your x squared is, in fact, bigger than 1. Same process, just 2 different possibilities. And then we have what's known as a 4-term polynomial. That would be literally 4 things on there. We were going to do factor by grouping for that kind of problem. So let's practice each technique. First, let's practice GCF. So greatest common factor. What you are doing is you are trying to find what is common between all of the terms available. So on example 1 here, it looks like they both at least have an x. They do not have a 4 in both of them, nor a 2. So it looks like all I can do is factor out an x. And if I factor out an x, technically what you're doing is you're dividing each of these guys by x. And technically, I like to think of it as x times what would have given me 4x to the 4th, which in that case would be 4x to the 3rd. Okay, because if I multiply the x's, I would add those exponents, the 1 and the 3. And if I take an x out of negative 7x, I would just get a negative 7. Now notice there's no equal sign, so we're not actually solving these ones. We're just going to get that for our answer there. Number 2, they all have a 4 in the numbers, so I got to factor out a 4. All of them have 1x to give. Not all of them have a y though, so I can't factor out a y out of everybody. So I will get 7xy plus 4x to the 4th plus 2y squared. Double check here. 4 times 7 is 28. X times x is x squared. Y 16, x to the 15th. Yep, there we go. Can't factor anything else out. I could have taken a y if this middle term right here would have been a y, had a y in it, but it doesn't, so we can't go any further. Okay, Now let's try trinomial factoring when my a is 1. Now, first thing we need to do, because now notice we're solving, I need to be equal to 0 or equal to 0. So everybody has to get on one side. And I like to, when I'm doing this, I like to make it so that my x squared stays positive because it makes my factoring a lot easier. So I'm going to move the 2x squared to the other side. I'm going to move the 2x to the other side. And I'm going to add 13. Okay, so I'm going to get x squared minus 10x plus 16 equals 0 on my case there. So now what I need to do, since it's a trinomial and I'm finally equal to 0, what I'm going to do is I'm going to set out my two parenthesis sets. And I'm going to have to ask myself some very important questions. The first question I'm going to ask myself is, what two things would multiply to give us an x squared? Well, you're probably saying, well, Marsh, x and x, right? X times x is x squared. Next thing I'm going to do is I'm going to ask myself, what two things multiply to give us 16? Not even looking at the positive, just wondering about 16. So 1 and 16 would give me 16, right? 2 and 8 would give me 16. 4 and 4 will give me 16 when I multiply. I'm going to pick 2 and 8. I'm going to put those guys in the back there. Then what I'm going to do is I'm going to multiply the outside numbers and the inside numbers. So I'm going to multiply x times 8, and I'm going to get 8x. And I'll multiply 2 and x. I'm going to get 2x. Then I'm going to ask myself, can an 8x and a 2x with any signs possible make me a negative 10? Ooh. Yes, right? Double negative, right? So then I'm going to double check. Two negatives, negative 8 times negative 2, does in fact give me a negative 16, so I can keep going. I'm going to put a subtraction in between both of them. Now, I am still equal to 0. I am not done, so I need to set x minus 2 equal to 0, get x equals 2 for one of my answers. And then I'm going to set x minus 8 equal to 0 and get x equals 8 for my other answer. Takes a little bit, just a lot of thinking, really. All right, let's try another one. So I have 3x squared plus 9x minus 30. Well, I'm equal to 0. I am now wondering if it's not a GCF hiding in here. So let's factor out, looks like a 3. So let's take a 3 out of everybody. 3x minus 10 equals 0. Okay, now I can factor x squared plus 3x minus 10. So again, I'm going to set out my two parentheses sets. Notice this 3, he's just coming along for the ride, really. Again, what times what gives me x squared? X times x, right? Two things that multiply to give us 10. Well, we got 1 and 10, 2 and 5. I think that's it. Let's pick 2 and 5. Because 1 and 10 is kind of big, and I need to get 3 ultimately. Multiply our outsides. We're going to get 5x. Insides, we're going to get 2x. Can a 5x and a 2x make a 3x somehow? Yes, right? If I had a positive 5 and a negative 2, I could get a positive 3. And if I multiply 5 times negative 2, I get a negative 10, just like we were hoping for. So now I got to transfer those signs to their respective numbers. So plus 5 minus 2. Don't forget, you're equal to 0. We've got to keep going. So now I'm going to set each thing equal to 0. Well, 3 equaling 0 doesn't make sense, right? 3 does not equal 0. So I don't need to worry about that 3. He's literally there just to bother me. So I'm just going to set x minus 2 equal to 0, and I'm going to set x plus 5 equal to 0. I'm going to get x equals 2 and x equals negative 5 for two answers to this problem. Let's try a is greater than 1. Dun, dun, dun. Okay, same steps. You need to be equal to 0. So on this one, I'm equal to 0. Double check GCF. Womp womp. No GCF. So I'm going to have to set out my two parenthesis sets. This one's a little different because I have 5x squared now. I need to multiply two things to give me 5x squared, which would be probably a 5x and an x, right? 5x times x is 5x squared. Now I need to ask myself what things multiply to give us 18. So we'll get 1 and 18, 2 and 9, 3 and 6, all options available. I have a 1 in the middle, so I don't really want to get too big. Let's try 3 and 6. Okay, I'm going to multiply the outsides. 5x times 6. Ooh, that's 30x. That's really big. 3 times x, that's 3x. Oop, that's never going to give me a 1. Let's do a quick erase there. Oh, lost my bracket. Let's try 2 and 9. And I'm not going to put the 9 with the 5. I'm going to put it with the 2 because I don't want big numbers, right? 5x times 2 is 10x. 9 times x is 9x. Can a 10x and a 9x make a negative 1? Yes, right? A negative 10 plus 9, that would give you negative 1. So now I'm going to transfer my answers up here. I have a minus 10, which was 5x times 2, and a positive 9, just like so fashioned. And then I'm going to double check. 9 times negative 2 does in fact give me negative 18. That is the one thing when you're doing this method. Make sure that you multiply the last two numbers to make sure you have the right sign on the end there. So that means I need to set 5x plus 9 equal to 0 and x minus 2 equal to 0. So I'm going to get x equals negative 9/5 over here and x equals 2 over there. I know, kind of a lot, but factoring is really fun. It's kind of like a puzzle. Number 2, I need to get 70 over because I'm not equal to 0, right? So I got 12x squared plus 2x minus 70 equals 0. Looking at this, there is a GCF, so we better take that 2 out. So I'm going to get 6x squared plus x minus 35 equals 0. Okay. 2 sits out front. 6x squared. I can make 6x squared using a 3x and a 2x or a 6x and a 1x. Let's a 3x and a 2x. Let's try that. Not sure if it's right. We're just going to try it. We're spitballing here. 35. Things that make 35. 1 and 35. And I think 5 and 7. Let's try 5 here, 7 there. 3x times 5 is 15x. 7 times 2x is 14x. Can a 15x and a 14x make a positive 1x? Yes, right? If it was a positive 15 and a negative 14, that would cause that. So now let's transfer our signs up. So 3x times 5 gave me 15x, so I need that to be a positive. And then I need the other guy to be negative. Negative 7 times 5 also gives us that negative 35 that we're looking for. So 2 cannot equal 0, so I'm not going to worry about the 2 sitting out front. I'm going to get 3x minus 7 equals 0, and 2x plus 5 equals 0. So x can either be 7/3 or negative 5/2. Awesome. I'm going to have you try example 3 on your own. Oh, yo. So try that one. Combine, make sure you're equal to 0. You should get answers at the end. So go ahead and pause the video here and see what you get for an answer. Okay, when you're done with your factoring, there was no GCF. So I got, for answers, x equals 2/3 and x equals negative 1. So double check your answers. Make sure you got the same as me. Okay, let's try one more. Notice something on this one. They're equal to 0. Don't have to worry about that. But I bet there's a GCF hiding in here. And I think it might be, I want to say 3, but I'm not too sure. Let's check. 52 divided by 3. Ooh, that doesn't come out nice. Oh, there's not. We can just take an x out, though. So let's factor out an x. I was really hoping for easier numbers, but guess not. Okay, let's factor. So I'm going to get, let's do 3x and 4x for 12x squared. Things that make 9. 1 and 9, 3 and 3 probably. let's try, I want to get 52, so I need a big, big number. Let's put 9 and 1 there. So 9 times 4x is 36x, and a 3x, that's not going to make me 52. Okay, we need bigger numbers. Let's try, instead of 4x and 3x, what about a 2x and a 6x? Because I need big, big numbers. Let's do 9 and 1 again. I'm going to multiply the 9 by 6 because that's a big number. And then a 1 there. I'm going to get 54x for the insides and 2x from the outsides. Woof, I can make 52 because a positive 54 and a negative 2 will accomplish the task, right? So I'm going to get a negative 2x, positive 54x. Change my signs there, get my signs up there. This one, we do actually have to worry about this outside guy. So we're going to set him equal to 0. So we're going to say x equals 0. Ta-da! For our first problem. Then we're going to set 2x plus 9 equal to 0. We'll get negative 9 halves. And then x, 6x minus 1 equals 0. That is x equals 1/6. Those would be our 3 answers, because I started with a cubed. That's why I'm getting 3 answers for that problem. All right, difference of perfect squares. My absolute favorite one because it's so fast. This is when you have 2 terms, so you have 2 numbers. It's a binomial. When you are looking for difference of perfect squares, you have to have 2 things. You have to have subtraction, aka difference, and you need to have perfect squares. That is numbers like 1, 4, 9, 16, 25, numbers like that. Okay? So now I'm going to double check that. I have a square, and I have a square, and I have a minus in the middle. So what we're going to do is we're going to set out our 2 parenthesis sets. But here's the best part about it is literally it's going to be the exact same thing twice, but one's going to have a plus in the middle, one's going to have a minus in the middle. And honestly, it's the square root of the 2 things. So x squared, square root of that is x and x. Square root of 100 is 10. And then 1 plus, 1 minus. Ultimately, this is just that trinomial factoring we just did, but notice there would have been a 0x in the middle, and we would have been able to do the exact same steps. We would have said, well, x times x gives me x squared. What things make me 100? 10 and 10. I would have a 10x and a 10x to make me a 0x. I would need 1 plus, 1 minus. That's what we're ultimately doing. So on this one, I'm going to get 2 answers. X equals 10, x equals negative 10. Okay, let's try it again. So I got 4x squared minus 9 equals 0. So perfect square, minus in the middle. So we're going to be able to set our 2 parenthesis sets out because this works for a difference of perfect squares. 2 things would be a 2x and a 2x because that would give me a 4x squared. And just like last time, we're going to do the square root of the number. So 3 and 3, 1 plus, 1 minus to get that 0x in the middle like we were looking for. So we'll get answers of negative 3 halves and positive 3 halves. Okay. Let's try this one. So I'm not equal to 0. Let's get equal to 0. So I'm going to subtract 50. Well, and you're probably thinking, Marsh, those are not perfect squares. You're right. I bet there's a GCF. So let's factor out a 2. I think they both share a 2. There we go. Now we got perfect squares and subtraction in the middle. So we're going to get 4x plus 5 and 4x minus 5 because they are perfect squares, 16 and 25. So I'm going to get x equals negative 5/4 and x equals positive 5/4. Okay, number 4. I'm going to have you do number 4 on your own. Oh, yo. Okay, so try that one. You should get an answer of x equals 9 and x equals negative 9. So try that one on your own. See if you can get those 2 answers. Okay, let's try grouping. Grouping is the one that's kind of a different beast because we don't see him a lot and we kind of forget that he exists. But when we do grouping, we need to have 4 terms. 1, 2, 3, 4. And what we're going to do is first make sure you equal to 0. And then also, of course, make sure you don't have a GCF, which in this case, we don't have a GCF. So what we're going to do is we're going to do a quick grouping. So what we're going to do is we're going to group the first two terms together and group the second two terms together. Something like that. Then what we're going to do is we're going to GCF both groups. So I'm going to take the greatest common factor of 2x cubed and 12x squared. That would give us a 2x. That's common between the two of them. And let's factor it out. I would get x squared plus 6. Oh, actually, let's take an x squared out. Marsh almost missed that. So I'd get x plus 6 if I did that. Now let's take a negative 5 out, like so fashioned. If I get that, I'll get x plus 6 out, because notice they both had a negative. That's why I knew to take that negative out. Now, a good thing to note, you always want, at the end of your grouping problem, the guy that you have left behind, you want it to be the same on both of the problems. So you want it to be x plus 6 on both. So I have x plus 6 on both. Now what I'm going to do is factor out what's common between these two factors, which is x plus 6, right? They both have an x plus 6. So if I factor that out, both pieces would be left with a 2x squared and a minus 5, the outside guys. Now I get to solve. So I have x plus 6 equal to 0, so x equals negative 6 for one of our answers. And then 2x squared minus 5, we're going to set him equal to 0. Oh, he's not a difference of perfect squares, so I guess I just need to solve this the good old-fashioned way. So I'm going to add 5, divide by 2. So I'm going to get x squared equals 5 divided by 2. Take the square root of a fraction. Gross. So I'm going to get x equals plus or minus the square root of 5 over 2. Now, I can't leave a fraction under a square root. We have to simplify that. So we're going to do a quick little sidebar combo up here. If I have a square root with a fraction underneath, what you can do is simplify that by square rooting the top and the bottom. So that is an illegal thing. I know it looks kind of silly, and you're like, that's not real math, but it actually is. But then what I have to do is take care of the square root of 2 because we can't have a radical in the denominator anymore. So I'm going to multiply by the square root of 2, top and bottom. And we will get square root of 10 over 2 for our final answer. Like so fashioned. Kind of weird, right? Kind of strange, but it works wonderfully. Don't leave a fraction under the radical. Make sure you simplify that for yourself, please. Okay, let's try another one. So I need to be equal to 0 first. So I'm going to move everybody from the right to the left. So I'm going to get 2x cubed plus 3x squared minus 16x plus 24 equal to 0. Not everyone has a common factor, so we need to do grouping right away. These two in this group have a x squared available, 2x plus 3 left behind. These guys have an 8 available. Oh, this would be a minus 24. Whoops, missed that. Let's take a negative 8 out. In that case, I would have 2x plus 3 left, right? If I divided both of these guys by that. So then I would get 2x plus 3 needs to factor out of both these two terms. Left with x squared minus 8. Okay, let's set the two things equal. So I'm going to set 2x plus 3 equal to 0. I'm going to get negative 3 halves for that answer. And then x squared minus 8 has to be set equal to 0. This one, again, we cannot solve it using difference of perfect squares. So we're just going to move the 8 over, take a square root. I'm going to get x equals plus or minus the square root of 8. Now, we can't leave it the square root of 8 because that's not a simplified radical. So I'm going to find perfect square and the number that multiplies that perfect square to get me that. Square root of 4 is 2. So I'll get 2 square roots of 2. I know, a lot. Lots and lots of rememberings today. Let's try one more, and then I'm going to have you do one on your own. So everything's equal to 0. let's just immediately do some grouping, right? Because there's no GCF in these guys. I can take a 2x squared out. I will be left with x plus 2 there. Now you're probably looking at the second one. You're like, Marsh, x plus 2 doesn't have anything in common. If they don't have anything in common, you're technically going to pull out a positive 1. You're just going to factor out that positive 1, aka I got nothing. Okay, both have an x plus 2, so let's factor that out. I'll be left with 2x squared plus 1 equals 0. So, setting equal to 0, x plus 2 equals 0. I get negative 2 for one of my answers. 2x squared plus 1 equals 0. 1. Divide by 2. I'll get x squared equals negative 1/2 square. Hold up. I can't take the square root of a negative number. That doesn't work. So this one has no answer. Okay, so there's no answer. We need to stop here. So our only answer to this problem is, only real answer to this problem is negative 2. Later in the year, we'll be taking care of that. But right now, we can't. We can't take care of square roots with negatives underneath. So our only answer, real answer, is negative 2. Okay, try this one, on your own. See if you can get the answer for this problem as well. Okay, once I did my grouping, I got x squared minus 4 and 3x plus 1, right? Now, x squared minus 4, that is a difference of perfect squares. So I'm just going to break that apart. You could set that equal to 0, and in fact, you could then have gotten the same answer as I'm going to. However, I like to break down if I can factor further. I like to factor my answer further. So I'm going to get 3 answers of negative 2, 2, and negative 1/3 for final answer there. That is the end of this very long factoring video. I know factoring is a skill that you might not be exactly comfortable with yet. However, that is something that we're going to work on quite a bit in this class. We're going to make sure that we can factor so fast and so quickly that you're even going to know how quick factoring can be. We will keep practicing this, and I look forward to seeing you later, Sabers.